Have you ever looked up at the night sky and felt a sense of wonder? Countless stars twinkle like diamonds scattered across a black velvet cloth, each one a distant sun, perhaps with planets of its own. Our Earth, this vibrant sphere teeming with life, seems like a tiny oasis in the vastness of space. But have you ever wondered, how did it all begin? How did our Earth, the very ground beneath our feet, come to be? It's a question that has fascinated humanity for millennia. Ancient civilizations wove elaborate myths and legends to explain the creation of the world. Today, thanks to centuries of scientific inquiry, we have a deeper, more awe-inspiring understanding of our planet's birth. It's a story that stretches back billions of years, a tale of cosmic collisions, fiery upheavals, and the slow, patient march of time. Our journey begins not on Earth, but in the heart of a universe yet to be born. In the beginning, there was nothing but unimaginable heat and density. The conditions were so extreme that our current understanding of physics breaks down. Then, in an instant, everything changed. This moment marked the birth of our universe. The universe exploded into existence in a cataclysmic event we call the Big Bang. This explosion wasn't like any explosion we know. It was the rapid expansion of space itself. Time and space, as we know them, began. Before this event, there was no time, no space, just a singularity. Imagine a balloon being inflated, its surface expanding outward at an incredible rate. This analogy helps us visualize the rapid expansion of the universe. That's a simplified way to picture the expansion of the universe. This expansion was not uniform. It varied in different regions, leading to the formation of structures we see today. As the universe expanded and cooled, energy began to transform into matter. This process is known as nucleosynthesis. The fundamental building blocks of everything we see around us, protons, neutrons, and electrons, started to form. These particles are the foundation of all matter. It was a chaotic and violent time. The universe was a hot, dense plasma where particles constantly collided and interacted. The early universe was a seething cauldron of particles colliding at unimaginable speeds. These collisions were crucial for the formation of complex structures. But amidst this chaos, order began to emerge. Patterns started to form, leading to the creation of the first atoms. Gravity, the fundamental force that draws matter together, started to exert its influence. It played a key role in shaping the universe. Over millions of years, gravity drew these particles together into vast clouds of hydrogen and helium. These were the first elements to form. These clouds, the seeds of future galaxies, swirled and churned, their destinies shaped by the relentless pull of gravity. They began to coalesce into larger structures. Within these clouds, the stage was set for the next chapter in the universe's story, the birth of stars. These stars would go on to create heavier elements, paving the way for planets and life. Deep within the swirling clouds of hydrogen and helium, the birthplace of stars, a cosmic dance begins. Gravity, the invisible hand of the universe, continued to pull matter inward, drawing these gases closer together. As the clouds contracted, they spun faster and faster, like a spinning figure skater pulling in their arms, conserving angular momentum. The pressure and temperature at the center of these clouds became immense. Then, something extraordinary happened, a phenomenon that would change the cosmos forever. The pressure and heat became so intense that hydrogen atoms, the simplest and most abundant element in the universe, began to fuse together, creating helium in a process known as nuclear fusion. This fusion released an incredible amount of energy, igniting the first stars, lighting up the universe for the very first time. These early stars were giants, much larger and hotter than our own sun, their immense size and heat making them truly spectacular. They blazed with a fierce intensity, illuminating the surrounding darkness, casting light across the vast expanse of space. But their lives were relatively short, ending in spectacular supernova explosions, a dramatic finale to their brilliant existence. These supernovae were not just destructive events, they were also incredibly creative. They were cosmic furnaces, forging heavier elements like carbon, oxygen, and iron in their fiery cores, elements essential for life as we know it. These elements, scattered back into space by the supernova explosions, would become the building blocks of planets, stars, and ultimately, life itself, seeding the universe with the ingredients for future generations of stars and planets. About 4.6 billion years ago, in a quiet and unassuming corner of the Milky Way galaxy, a giant molecular cloud began to collapse under its own gravity. This cloud, a vast and sprawling nebula of gas and dust left over from previous generations of stars, was our cosmic cradle, the birthplace of our solar system. It was a chaotic yet beautiful nursery of stellar material. As the nebula collapsed under its own gravity, it began to spin faster and faster, much like a figure skater pulling in their arms to spin more rapidly. This spinning motion caused the cloud to flatten into a rotating disk, with most of the mass concentrating at the center, forming a dense core. This central mass, growing ever denser and hotter, would eventually ignite nuclear fusion and become our sun, the star at the heart of our solar system. Within the swirling disk of gas and dust, tiny particles began to collide and stick together in a process known as accretion. This was the beginning of planet formation. These particles grew larger and larger over time, forming pebbles, then boulders, and eventually planetesimals. These planetesimals are the building blocks of planets, the seeds from which planets would grow. The inner region of the disk, closer to the young sun, was significantly hotter than the outer region, creating a temperature gradient. This temperature gradient played a crucial role in determining the composition of the planets that would form. The varying temperatures influenced which materials could condense and solidify, leading to the diverse array of planets we see in our solar system today. Imagine, if you will, a time when our planet was a molten ball of fire and chaos. In those early days, Earth was a hostile place, with volcanic eruptions and meteor strikes shaping its surface. The air was thick with toxic gases, and the ground was an ever-shifting landscape of molten rock. It's hard to believe, but this tumultuous period laid the foundation for the planet we know today. Over millions of years, the Earth began to cool, forming a solid crust and eventually creating the conditions necessary for life to emerge. It's a story of transformation and resilience, a testament to the incredible power of nature. Billions of years ago, a colossal impact between Earth and a Mars-sized body led to the formation of our moon. This celestial event was not just a random collision. It played a crucial role in shaping the Earth as we know it. The moon's gravitational influence stabilized our planet's wobble, leading to more predictable seasons and a climate that could support life. As Earth cooled, volcanic eruptions released gases that formed our early atmosphere. Over time, water vapor condensed to form oceans, covering much of the planet's surface. These vast bodies of water became the cradle of life, setting the stage for the next chapter in Earth's history. In these primordial oceans, simple life forms began to emerge. Microscopic organisms, such as bacteria and archaea, thrived in the nutrient-rich waters. These early life forms were the pioneers, setting the foundation for the complex web of life that would eventually evolve. As we reflect on our cosmic origins, we realize that every element in our bodies was forged in the heart of a star. From the moon's dramatic arrival to the emergence of life in our oceans, our journey is a testament to the intricate and interconnected nature of the universe. It's a story that reminds us of our place in the cosmos and the remarkable events that led to our existence.